Okay, for today, the official title is More with Functions. Basically, we're reviewing what we did yesterday on part A here. We go f of x plus h minus f of x, difference quotient, actually. It helps you when you're in calculus. It helps you to find the slope at a certain point, the secant line. All right, so anyway, you won't really use this until later, but you're going to use it now to just stick in x plus h into a function. We'll review that in a minute. And then today's main new stuff is if we have variables that get thrown in with our functions. In other words, instead of just y and x, you might have y equals x plus a. If you throw in another variable, that's classic pre-calculus. Because now you've had two variables before, now we throw in three. And we're trying to figure out what happens with that third variable. It's really not super hard. It's just usually making it shift up or down or left or right. And so the third variable is kind of just like a shift. All right. So on this one, I had the kids do f of 4 before, and they stuck the 4 in there, and I think we got 31 for that one. Now we're doing part B, and we stuck in 5 for f of x, so 5 went right in there. So now here's our equation. Adding 1 to both sides, 6 equals 2x squared. Dividing by 2, 3 equals x squared. Square rooting, x equals square root of 3. My worst nightmare. Because this kid has to get it marked wrong. And all they missed was what? Yes? The absolute value of x. Then you may give it two answers. X equals square root of 3. X equals negative square root of 3. No, you may not just jump to x equals plus and minus the square root of 3 without saying what's happening. Too many kids don't know there's an absolute value there, and they think they can just slap a plus minus on it and it'll all be better. And that's not correct. And it does mess you up later. Think that. And usually the problem is that people think that the square root of 16 is two things. And it's not. Square root of 16 is just, when you write it this way, that means the positive answer has to be 4, not 4 and negative 4. Okay, so back to this one. Now put in c plus 1. I know a lot of you already have, and I appreciate you being on top of things like that. If you've already stuck in c plus 1, this will obviously be a little bit of a boring time for you, but would you please carefully put that in, multiply it all the way out, simplify it down, and see what you get. I will pause for a second while you give that a try. Okay, here's this first one. I'm sticking in c plus 1 where that used to be. So I'm having 2 and then c plus 1 squared and then minus 1. Then I'm going to stretch this out. C plus 1 squared really means c plus 1 and another c plus 1 like that. Then I'm going to multiply it all the way out. C times c squared, outside and inside makes plus 2c. Lasts make plus 1, not 2. Then I got to times all that by 2. Notice the parentheses again. I'd say parentheses cost kids more points in this next month than anything else. Be careful with those parentheses. 2c squared plus 4c plus 2 minus 1, and the plus 2 minus 1 go together and say plus 1. Raise your hand if you had that one right. That's most of you, almost all of you. All right. If you made a mistake, hopefully you just can see where it was. This one, you're sticking in x plus h in there and getting it all multiplied out. That's a lot like the other one. The only thing is, at the end you have to subtract f of x. Well, what's f of x? Just subtract that, but just be careful again with parentheses. Simplify it all down. I'll give you this hint. Your answer has two terms in it. If you did it right, your answer has something plus something, or something minus something. Just two terms. Everything else should have canceled. Otherwise, look through your work. Try to figure out where you went wrong. Yes? Okay, so here's how I'd start this one. X plus h has to get squared. And all this is right here is reiterating this, except replacing x with x plus h. Then I have this part where I subtract f of x. Very common to mess this up by, instead of having just slapped f of x right here, you really should have put a parenthesis around it. Again, why? Because it's a variable. F of x is like a variable. It's like a y. And you're replacing it with something. So you put an empty parentheses and you drop in that thing. Really important to have that in parentheses. So if I multiply this all out, I'm going to try to do it quickly here. 2x squared plus 4xh, or hx, doesn't matter, plus 2h squared minus 1, and then put all that with it, minus 2x squared plus 1, because I distributed this out. All it takes is one little plus sign to make your answer totally different. So now this plus 1 and this minus 1 cancel. This negative 2x squared and this positive 2x squared cancel. That's what's left. 4xh plus 2h squared in either order. You can reverse them if you want. Yes? If you can factor it, you should. So yeah, you can definitely factor out a 2 and an h. And then you'd have 2x plus 2h in your end parentheses. I like that. You don't have to. Kind of at the end of a problem, it doesn't help near as much to factor it as it does at the beginning. But it's totally okay and a good idea. All right. So that was the old stuff. That was all review. And this is the same exact kind of problem, except this one is a little different. Would you just quick stick that, evaluate this function given that? I'll say it that way. You're not putting a minus 4 in the function. I'll pause while you try that. Okay, so here's my function. 2 times something plus 1. That's this with a parenthesis put in. You really need those parentheses. Now I'm going to drop in what they tell me to drop in. They told me that the x part was a. So I put an a right there. That's how I find f of a. Then I'm supposed to subtract 4 at the end, so that's at the end. Now I could put parentheses here, but there really wouldn't do anything in this case. There's nothing to be distributed in front of the parentheses, and there's nothing I can do in them. If you're wondering how do you decide if you can drop parentheses, if you can't do anything inside it, and there's nothing in front of it, or multiplied by it after it, like nothing's operating on that, then you don't need the parentheses. Like if there was parentheses like this, and there's a 2 after it, that's going to multiply everything in it by 2, then you can't just drop the parentheses. But if there's nothing operating on the parentheses, then you can drop them. So then I have 2a minus 3. Raise your hand if you had 2a minus 3. Okay, good. Now let's move on to the new stuff for today. I want you to get what I've just graphed right here. Do you get that's the line y equals x? Does that ring a bell? You should know that one. Okay, good. Then, notice in this graph, I have this extra minus a going on. What's that going to do to it? Shift it. Which way? How do you know it's down? Because it's minus, but you don't know what a is. So what if they double reverse it on you and they put a negative 2 in for a? Do you get how that would make it go up? But they also promise not to do that. Where do they promise not to do that? A is bigger than 0, and therefore this has to be a positive number. Therefore you can, with confidence, say it's moving down. But do you know how far down it's moving? All right. So the question really boils down to this. You got to think it through like that and figure out where is this thing moving. And then what I strongly recommend for this kind of problem is that you say, okay, so I don't know if it's here. If a was 0, it would be there. So think about it for a second. Can my answer actually be there where the black line is? It has to be slightly what of it? Lower, below it. So I'm going to put a line below it, and it could be a little lower, and it could be lower, and it could be lower, and lower, and lower. And that's what I call a family of functions, because I don't know how big a is. So I don't know how far down it shifted. So now I got to give the domain and range of this thing, and it depends on what a is. Sometimes it depends on a. Sometimes, actually, it doesn't matter. Let's do the domain and range of the original. That's my best advice on these, is do the domain and range of the original and then figure out what changes. The domain of that black line, it goes from negative infinity to positive infinity. It never stops going from left to right. Range-wise, same thing. My question is, if I move it down, any of those red lines, is that changing its domain or range? No. In this case, it won't matter a bit. So A did not influence the answer. So what if, yep, that's the concept, you're right. So what if this had been a little different? What if it had been a parabola? We're not going to use that anymore. We're going to use what if y equaled x squared? And then you subtracted a. And a had to be a positive number. Then this thing was here. The green one is your original. My advice was to find the domain and range of that. So let's find the domain and range of the original graph. And then we'll figure out what happens when you change it by a. Good. And how about the range of it? 0 to infinity. Can it touch 0? Yep, it touches at 0. All right, because right there, the graph has a 0 for its y, and ranges are about the y's. Okay, so now my question is, where is the family? Above or below it? Below it, because it's minusing some positive number, so it's going to go down. It's subtracting a positive number. So there's the family of functions. Is the domain changing as it moves? No. Is the range changing as it moves? Yes. So now our range is no longer 0 to infinity. It's what? A is a positive number. Do you really want it to be like 3 to infinity? Negative a. Again, if you pick a number for a, some simple number like 2 or 3 or whatever, then think it through and go, well, if it's 3 to infinity, that's like above this. This is below it, so it needs to be negative a to infinity. All right. So that's the basics for today, is you're going to figure out what function you have, and then you're going to see what a is doing to your function. Typically, it's shifting it, right or left or up or down. One thing that's important for you to know is that if I stretch a function, it does not affect its domain and range. I want to show you an example of that, because you're going to have a couple stretches in your homework for tonight, and I wanted you to see that stretching it doesn't really change its domain and range. This one is the square root function. It can't go further this way. Why? It has to be an absolute value of it, because we're doing a square root, and if we do a square root of a negative 2, for instance, it won't work, will it? Okay, so y equals square root of x is the parent function here. What is its original, before I do anything with a, what's its original domain and range? Don't say it, write it. Everybody figure out this guy's domain and range before I make any changes to it. All right, a student gave me the domain and range of the original. They did it right. Now, what if I change this to, I'm going to take x and I'm going to minus a on the inside, where I'm going to say a is some positive number, and I'm going to add a to the outside, and that's going to take my function and move it. So now, I want you to write a little family of functions for this that shows where this thing might be moving, because you don't know exactly how big a is, but when it, pick a small number for it, like pick 1 for a, and see where would this thing move if a was 1? What if a was 2? And then kind of keep shifting it that way, and you'll know where this thing is moving. And that'll help you tell whether its domain is going to change based on a, or its range is going to change based on a, or both of them are going to change based on a. All right, so where is this minus a going to make him move? Right. Right, and there, where is this plus a going to make him move? Oh, so this, do you get my new family has got to be kind of to the right and up each time? That's where it's generally moving. Okay, now tell me, as this moves to the right and up, is it changing the domain? Yeah, it used to be 0 to infinity. Now it's like wherever that is to infinity. Yeah, domain changes. How about the range? Like how high it's going? The highest high is still infinity, but what's the lowest of the up-down? Is that changing? Yes, it is. So domain and range are both changing. So you take your domain and range and you tweak them using A. And you figure out, can you just always replace the first thing with A? No, you can't. Depends on the situation. All right, for the domain, that's the left, right. It's moving to the right. How far does it move to the right? A. How many you guys had from A to infinity? Good. And then the range, it's no longer going from 0 to infinity. It has to move up from there. And so it's now something above 0, whatever it is, I guess, is A. So it is A to infinity. And no, you can't just always stick an A at the beginning of your domain and range. That doesn't work. Because it depends. Sometimes it's moving down and you'd have to have negative A. Sometimes the highest the function goes could be affected, and then that would change this. Like, for instance, some functions have a limit at the top because they have an asymptote up here. And if you move the whole function down, now the highest they can go moves down. So it depends on the function. So I can't just give you a blanket rule that you can stick the A at the beginning. Wish you could. All right. So homework for today. If I find it with me, here's the first one. It is identical to the one we just did in class a few minutes ago with one little tweak. It's the line y equals x, except shifted down. That's all true. What's different about this one? X has to be less than 0. What does that mean? Well, here's y equals x. You start by graphing what you know. All right, I know that's the line y equals x, and I'm off a smidge, but it's something like that. Okay. Now, what if x has to be less than 0? Which of these points are no longer possible? The ones on the right or the ones on the left are no longer possible? The ones on the right are no longer possible because this is where x is like 1 and 2 and 3 and 4. All right, see how that has to stop right there now? Because they said so, x has to be less than 0. That limits my original function to this. And it doesn't go both directions forever. It stops right there. It can't go further to the right because it says so. Now, what I would do if I were you is find the domain and range, except the directions here, we are really focusing on the domain, or sorry, the range of these functions. It says only find the range. You don't have to find the domain. Okay, so let's focus on the range. What's the range of this original function? So you got to ask yourself, what's the lowest it goes, comma, what's the highest it goes? Negative infinity, comma, 0. Good. That's range is about how low to how high. Now, will A change that? What do I need to draw on my graph now? The family of functions this will be. As A gets bigger and bigger, where is this thing going to move? Straight down. That. There's my family of functions. So tell me, is my range changing? Yes. And then I can say, okay, it's not the negative infinity changes. It still goes to negative infinity. So you figure out where to change your range. This is one of your homework problems. I just wanted to help you through one. The next one, this one, is one of those square roots. Remember me telling you, actually I never showed you. If I have a square root and then I stretch the square root, make it twice as tall, do you get its domain and range didn't change? All right, so for the functions that we're doing, when you stretch something like this, don't let that freak you out. It doesn't change its domain and range. Okay. I'm sure you can find functions where it does, but all right, now this one I would start by sketching what you think it looks like without the A's. Then I'd figure out, okay, where's the family of functions going to be? Where does this whole thing move once I do have it, the A in action? And then I would write the range. These are only ranges. Okay? This one's the most challenging one because people don't know what it looks like. If you don't know what it looks like in the first place, which I understand why you wouldn't, then pick a number for A that's small. It says A's got to be bigger than 0, so let's just pick the easiest thing. Let's pick A as 1. Graph it like this. If you have to, use a calculator and graph it. But you can graph something like this by just going x and y, stick in a few numbers. What if x was 0? Then I'd have 1 over 0, and that's impossible. So the graph doesn't exist where x is 0. Then I stick in something like x is 1, and I have 1 over 1 plus 1, which is 2. So 1 comma 2 is on my graph. And then I stick in 2, and I have 1 over 2 is 1/2 plus 1. 1/2 plus 1 is 1 and 1/2. So over 2 up 1 1/2. Looks like it's going to get lower and lower and lower and lower. And I'm guessing that the lowest it'll ever be is 1. Because look, I'm always adding 1. But that little graph, like this, and probably this, is how I started when I assumed A was 1. What if A gets bigger and bigger and bigger? Where is it going to move? That's what you have to figure out. Is does this thing, as you change this to A is like something bigger, like 2, figure out where the thing moves. Does it move up? Does it move to the left or to the right? Because that's what will affect your range. Left and right don't affect your range. It's only the up and down that do. All right, so what's the range on that thing in the first place? Well, it's as low as, actually the lowest thing it can be, since you're adding 1 to whatever you get, is 1. The lowest it could ever be is 1. And it can't actually be 1. But the highest it can be, it has an arrow going up here, is infinity. So you find the range of the original, then you try to tweak it to figure out where did it go. All right, enough help on that. Then this is a review totally of yesterday. It should be easy. I am feeling like number 17 is a little unnecessary, so you may skip number 17. So this guy right here, second one on the bird page. Okay, and then there's these two, and they are easy if you know all you're doing here is sticking in that x is 0, and here x is not 0, but what is 0? Y is 0, or f of x. So 0 goes there on that problem. 0 equals blah, 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 and then you solve it. So you're just sticking numbers in and solving it. Here you're sticking 0 in for x, here you're sticking 0 in for y, which is right there. And this one will make you think, what will make it equal 0? I'll give you a hint. You don't care about the bottom of it. To make something 0, you don't make the bottom 0 because it actually doesn't work. Bottom being 0 crashes. You want to make the top 0. And, what's my favorite saying? Can factor it. You should. Bet you can probably factor that. Probably should. All right. Okay, that's all I got for you. This number 30 is double circled. If you ever see that, it's usually an indication that that's kind of an important problem. It means you might see another one like it on a test someday, or it's got some nugget of information that's really important. And once again, try to remember my favorite saying because it comes in handy often. All right, and the old assignment, if you look further down, it looks like there's all these old other homework problems. That's just yesterday's homework. So, all right, that's all I got for you for today.